So we're told here that an aluminium atom has a mass number of 27, an atomic number of 13. So let's put those into a format that we're used to seeing on the periodic table. And it wants us to work out the number of subatomic particles in aluminium ion. Okay, so if we think about the atom first of all, this means there are 13 protons. 27 take away 13 is 14 neutrons. And because there are 13 protons, there would also be 13 electrons. If you've got 13 electrons, you would arrange them as 2, 8, 3. Remember, that's not stable. It would want to lose those 3 to become stable. So that helps us identify in the ion, it would only actually have 10 electrons. So if we check over here what we've got, this has got too many electrons, as has this one. We've got 2 here with 10, so they could both be right. But option B has got 14 neutrons and 13 protons. So it's option B. Okay, magnesium burns in excess to form magnesium oxide, starting with 1.35, let's put that on there, 1.35 grams of magnesium. Calculate the mass of this that would be formed. Okay, and we're told the relative atomic mass. You must show you're working out. So the first thing to do is we need to work out the moles of the magnesium. Now over here, let's put a reminder that Mr. Moles is underneath the mass. So I've got moles of the magnesium is the mass divided by the MR. So the mass divided by the MR. The mass in this case is 1.35, and the MR for magnesium, it tells me here, is 24. So what I'm going to do first of all is do 1.35 divided by 24, and that's going to give me 0.0563, just rounding that last one up, moles. Next, we deal with the stoichiometry, the ratio of the equation, and you can see here there are 2 moles of magnesium to 2 moles of magnesium oxide. So let's just put that so we remember. 2 lots of magnesium to 2 lots of magnesium oxide. Therefore, if I've got 0.0563 moles of this, then I'm going to have exactly the same, because that's exactly the same number. 2 to 2 will be 0.0563 moles of this. Okay, then all I've got to do is convert this back into a mass it wants me to give. So mass of the magnesium oxide. So again, according to my triangle up here, if I want to find the mass is MR times moles. So here I have got the MR times by the moles. So the MR for magnesium oxide, now be careful, we've got to do some working out. So let's do a little bit up here. MgO is 1, magnesium is 24, and then I've got an oxygen which is 16. So that's going to give me a total of 40 as a relative formula mass of the MR. So 40 times by this 0.0563. So let's times that by 40, and I'm getting an answer here of 2.25. Just check, does it ask me to give any decimal places? It doesn't. So I've got 2.25 grams in there. Mark wise, there are 3 marks. So you're going to get 1 mark for working out the number of moles, 1 mark for working out the MR, and then 1 mark for finding the final answer. You won't get a mark for the ratio because here it's just a 2 to 2 ratio. Carrying on, we're told that chlorine reacts with hydrogen to form hydrogen chloride. Write a balanced equation. Now be careful, chlorine is Cl2, it's diatomic, and hydrogen is H2, it is also diatomic. Hydrogen chloride, if you've forgotten how to work out the formula, Hydrogen is a +1 ion, so it wants to make one bond, and a chloride ion is a -1 bond, so a negative ion, so it wants to make one bond. Two numbers are the same, so just swap them over. So H gets a 1, Cl gets a 1, so that's just going to be HCl. I've got two Cl's here and two H's. I've only got one H and one Cl. So to balance this one, just put a big 2 in front and you have got a balanced equation. Marks wise, you're going to get 1 mark if you've got the Cl2 and H2, another mark for the HCl, and a third mark for completing the equation by balancing it. So we're told here that sodium is reacting with chlorine, and we've got electron configurations for sodium, and then we've got electron configuration for chlorine. Give the electron configuration for the ions forms. What's going to happen in here when they react is this electron here is going to be transferred to the chlorine. So that means my sodium will be 2,8 and my chlorine will be 2,8,8. So my chloride ion will be 2,8,8.